So this is question number 27. Fx is equal to kx square if x is less than equal to 2 and fx is equal to 3 if x is greater than 2. So this function is continuous at x is equal to 2. That much is given and we have to find values of k. Great. So for that, what is to be done? This is a simple answer but important. Fine. Let's move. This is given function kx square for the real number which are less than 2, and also 2 is included in this interval. Okay, and then for the right side of 2, that means fx is given as 3. Now given that the function is continuous at x is equal to 2, that is we already know, therefore this is the condition of continuity. Left hand limit is equal to right hand limit equal to value of the function at x is equal to 2. जब भी एक फंक्शन कंटिन्यूअस होता है जिस जगह पे, जिस पॉइंट पे और जिस इंटरवल में होता तो वो आर्बिट्रेरी पॉइंट में होगा, कोई भी पॉइंट में हो जाता है उस इंटरवल में, और फिर अभी तो 2 में कंटिन्यूअस इट इज गिवन. सो वी आर हैविंग वैल्यू ऑफ द फंक्शन एट x इज इक्वल टू 2, राइट हैंड लिमिट एंड लेफ्ट हैंड लिमिट. ओके, सो left hand limit at 2. See, left hand limit means x is approaching towards 2 from left. So in that case we use 2 negative, is not it? So limit of fx when x approaches 2 from left, and that means x tends to 2 negative, which is equal to limit of fx x tends to 2 positive. This is right hand limit. 2 positive means x is approaching towards 2 from right. Got it? So this is f of 2, value of the function at 2. Fine. Now limit kx square, 2 negative kx square. 2 negative means, you see it here, this x is less than 2, fx is equal to kx square. So for fx we will put kx square, isn't it? And then fx is equal to 3 we will substitute. Why? Because x tends to 2 positive. 2 positive means when x is greater than 2, then fx is to be 3. That is given us in the question. And when x is equal to 2, here equality sign is there, then we will use k2 square. This k2 square. Okay. Now going to find the limit of this kx square when x approaches to 2 is 2 square. We will get 4. And this is constant, is not it? So x has no effect on this 3 because it is constant, right? Then it is 4k. 4k equal to 3, 4k equal to 3. From that we can conclude 4k is equal to 3, from where we can get k is equal to 3 by 4. This is to be the value of k, what is to be found out, is not it? Now the question number 28. Here again we are going to find values of k. Here kx plus 1. But the point where the function is continuous is x is equal to pi. Got it? Then x less than equal to pi, in that case fx is equal to kx plus 1, and when right side of pi we will use fx is equal to cos. Fine. So this is the answer. Fx is equal to kx plus 1 and cos x. This domains. Given that the function is continuous at x is equal to pi. This much we got already. And then this is, we know, left hand limit is equal to right hand limit, which is equal to value of the function at x is equal to pi. Then left hand limit as x approaches to pi from the left. Then right hand limit, limit x tends to pi positive, fx is equal to f pi. Value of the function we are going to find at pi. Then limit x tends to pi negative, kx plus 1. Limit x tends to pi positive, cos x according to the question equal to pi k plus 1. This is value of the function at pi. Now pi k plus 1 is equal to minus 1. This is when x approaches to pi, cos x gives minus 1, isn't it? Pi k plus 1, pi k plus 1. So pi k plus 1 is equal to minus 1 is the equation. This is what our required equation, isn't it? From which we can get k minus 2 by pi. I think you understood. So I told you that the question is simple but important, right? Now this is question number 29. Now let us start the answer. Here fx is equal to this question, and then given that the function is continuous at x is equal to 5. Okay, nothing is there to explain. Therefore, left hand limit is equal to right hand limit is equal to value of the function at x is equal to 5, because the function is continuous at x is equal to 5. For this is obviously we will get, isn't it? Now left hand limit x tends to 5 negative, and then for right hand limit x tends to 5 positive of fx, f5. Now for fx, when x approaches 5 to 5 negative, that means x approaches to 5 from left, and then we will use our fx kx plus 1. So kx plus 1, we are using kx plus 1 for fx when x approaches to 5 negative, and then for fx when x approaches to 5 positive, we are going to use 3x minus 5, isn't it? You understood this much? ये समझ में आ रहा है? तो f5 जब x is equal to 5 होगा तब फंक्शन kx plus 1 यूज करना था. kx plus 1 इक्वल और 5 नेगेटिव दोनों के लिए kx plus 5 ही था. x का जगह में 5 बटेगा अभी. ओके, नाउ 5k plus 1, putting x is equal to 5, we will get this. Here we will get 3 into 5 minus 5, and then 5k plus 1. Okay, now 5k plus 1 will remain same. 3 into 5, 15, minus 5, 10, 5k plus 1. 5k plus 1 is equal to 10 is the required equation, is not it? From here we will get k. How? 1 is transposed to right, you see. 5k is equal to 10 minus 1. Fine. 5k is equal to 9. Then k is equal to 9 by 5. Okay, is there any problem? Nothing. I think it is simple. Find the values of a and the b such that the function defined by fx is equal 5 if x is less than equal to 2. Ax plus b if 2 is less than x less than 10. And then 21 if x is greater than equal to 10 is a continuous function. That means you are given that the function is continuous, and with this information we have to find the values of a and b. Here these two arbitrary constants are there in the question. So let us start. Here fx is this, and whatever is given in the question. Okay, now given that the function is continuous, this is our main information, and then the function is continuous at all real numbers. That's also it is given. Function is continuous means it is continuous in the domain. The function is defined for all real numbers, so it is continuous at all real numbers, isn't it? The function is continuous at all real numbers because you see here x is less than 2 means this part. These are all real numbers which are less than 2. Here fx is defined as 5. Okay, next this part 2 to 10, x is equal to ax plus b means the function is defined minus infinity to 2 and 2 to 10. At 2 is also it is defined, the equal sign is there, right? So minus infinity to 10 the function is defined. Now from 10 onwards this is 21, right? So that's why we can say that the function is continuous at all real numbers because of this domain is given, right? Let's proceed. Hence certainly the function is continuous at x is equal to 2 and x is equal to 10. Nothing to prove, because we know that this is continuous at all real numbers, and in real numbers 2 and 10 are also included, is not it? So from that we easily conclude that the function is continuous at 2 and 10. If it is continuous at 2, what can we write? We can write that left hand limit is equal to right hand limit is equal to value of the function at x is equal to 2. So when left hand limit is at 2, what do we write? 2 negative fx, right hand limit x tends to 2 positive fx, and f2 we know, and at 2 we know that it is 5, and for those real numbers which are greater than 2, fx is defined as ax plus b, and for the real numbers which are less than 2 defined as 5, fx is defined 5. Okay, so this is constant one, so nothing to be done, straight away 5, and this is 5, and ax plus b, let us put in x 2, so we will get twice a plus b. So our first equation will be twice a plus b is equal to 5. This is our required equation. One condition we got. Then we know that the function is continuous at 10. So we can write this statement. Left hand limit equal to right hand limit equal to value of the function at 10. Fine. Next part, I think you understand what is to be there. Limit x tends to 10 negative fx, limit x tends 10 plus fx equal to f of 10. And for the real numbers which are less than 10 but greater than 2, ax plus b was given, isn't it? And then the real numbers which are greater than fx is defined 21, this one, and f10 is equal to 21, right? So putting x is equal to 10, we will get 10a plus b, and then this is constant 21, 21. So second equation will be 10a plus b is equal to 21. Here subtracting 2 means this equation from 1. See, 2a plus b is equal to 5 was the first equation, and 10a plus b equal to 21 is the second equation. Subtracting this second equation means all sign where there is positive or negative, the sign will be reversed because we are going to subtract this, isn't it? Here it is plus sign is, so we'll think of it as a negative sign, minus 10a. So plus 2a minus 10a is equal to minus 8a. So plus b minus b get cancelled, and then 5, this is minus, so 5 minus 21 minus 16. Okay, then simplifying we will get a is equal to 2. So next you see, putting a is equal to 2 in twice a plus b is equal to 5. A is equal to 2 in twice a plus b equal to 5. Twice a plus b is equal to 5. We are going to put a is equal to 2 because we already got. So 2 into 2 plus b is equal to 5. 2 to 4 plus b 5. B is equal to 5 minus 4. This is transposed. 5 minus 4 is equal to 1. So we get b is equal to 1. So what is your answer? Your answer is a is equal to 2 and b is equal to 1. I think solving 1 and 2 we get a equal to 2 and b equal to 1. And these are the solutions of a and b. That is what we were to found, isn't it? So that's all. Thank you.